Welcome to Brain Vision.
65 centimeters. Frequency F1 is 329.6 hertz. On an acoustic guitar, the string typically has a diameter of 0.33 meters and is commonly made of brass, 760 kilogram density, while an electric guitar has a diameter of 0.25 millimeters and is made of nickel coated, 7,990 kilograms per meter cube density. So the high E string tension on an acoustic guitar versus an electric guitar. So we want to compare the E string tension on the acoustic versus the electric. And I wrote down what we were given, at least as far as what we're going to use. And you'll see why in a minute. The density of the acoustic, I write as rho A. Electric, I write as rho E. The diameter of the acoustic, dA, and the diameter of the electric, dE. Okay, well, the frequency, which we were told, is equal to the velocity of the sound in the medium divided by 2 times the length. And the velocity of sound is related to the tension, the force of the tension, we'll call that F sub T, divided by rho times pi r squared. Okay, so therefore now we can rewrite F is equal to 1 over 2L, 2 times the length, times the square root of Ft divided by, so that's the force of the tension, rho times pi r squared. Okay, so if we solve for the force of the tension in general, it's going to be equal to 4L squared rho times the frequency squared times pi times the radius squared. Okay, let's get a new page going. So for our situation, we want the force of the tension of the E string from the acoustic, we'll call that FTA, to the force of the tension of the electric, call that FTE. So this is going to be equal to, we have 4 pi. The length of A squared is the same as E squared, so we'll just write L squared from the acoustic and the electric since they're the same. Rho A times F squared, which is the same for the acoustic and the electric, times pi times RA squared. So this is 4 pi L squared. Now let's rewrite that. It doesn't look much like an L. L squared. This is rho E frequency squared pi RE squared. Okay. Well, let's use our red here. Everything that cancels, those are all going to cancel with all of that because that's the same. Frequency squared cancels. Pi cancels. And we're left with rho A over rho E, which we know. A little neater. Times RA squared over RE squared. The diameter is half the radius, right? Well, the half top and the bottom, so we can just write this as the diameter squared over diameter of A over the diameter of E. And these are both squared. So the ratio of radiuses is the same as the ratio of the diameters. We know the diameters. So let's plug in all the values, which we have written up top here, into this equation. And we find that this is equal to 1.7. So there's your ratio. Box that in.